Hey everyone, so in this video we're going to be looking at the big ideas for section 2.2. So let's start off with density curves. What are density curves? Well, the definition says this. A density curve is a graph that shows probability. So when we look at density curves, we are looking at a graph and we're looking at the area under the curve, which is going to give us a probability. So the area under a density curve is always equal to 1 or 100%. The density curve represents all of the data in a distribution, so that's why the area under the curve is 1 or 100%. And finally, density curves come in all shapes, but a bell-shaped density curve will be used the most in AP statistics. So it doesn't have to be a bell-shaped curve in order to be a density curve. We could have a curve that is skewed right or skewed left, or it could just be all kinds of crazy shapes. And they could all be considered density curves if we consider the area under the curve to be 1 or 100%, and we can find probabilities. So that's a little bit about density curves. The next big idea is the empirical rule. And with the empirical rule, I don't have it on here, but I would write that the empirical rule only works for bell-shaped distributions. In fact, let's go ahead and type this in. Only works for bell-shaped distributions. Okay, anything other than a bell-shaped distribution, you should not be applying the empirical rule. And then I'm just going to reveal this picture. And this gives you all the information you need to know about the empirical rule. The empirical rule is also called the 68, 95, 99.7 rule. So we can see that down here that 68% of the data is within one standard deviation of the mean, above or below. 95% of our data is within 2 standard deviations above or below the mean. And then 99.7% of our data is within 3 standard deviations above or below the mean. Now, I want to remind you, and we probably talked about this in class as well, the empirical rule is not exact. It's just an approximation. It is not exact. It's just an approximation. As we move forward in the course, we're gonna find some more exact ways to find the exact areas under the curve, but this is just a good approximation. We have one more big idea that we want to look at for section 2.2, and that is what happens with the mean and the median based on the shape of a distribution. So I misspelled this. I'm going to fix that there, based on shape. So we may have different shapes of distributions. This one in the top left here is bell-shaped and symmetric. But this one on the top right, it's symmetric, but it definitely is not bell-shaped. In fact, it's bimodal. It's got a peak and a valley and another peak. We would consider this bimodal, but it is symmetric. So how do the mean and the median relate to each other when we have symmetric distributions, whether or not it looks like a bell-shaped or something different? As long as it's bell-shaped, the mean and the median are equal to each other. So I'm going to put this right here and say the mean and median are equal in a symmetric distribution. So it doesn't matter whether it's bell-shaped or not. If you have a symmetric distribution, the mean and the median are going to be equal to each other. Now, what if we have a skewed distribution? What happens with the mean and the median? Well, if we look at this picture on the bottom left, we have a skewed right distribution. The tail is on the right, so this is skewed right. In this case, the mean is going to get pulled towards the tail. So the mean is going to get pulled over this way. And in this case, with a skewed right distribution, what we have is a situation where the median is less than the mean. And I think it's important to note that the value of the median is along the x-axis. So the value of the median is right here. The value of the mean is right here. So with a skewed right distribution, the median is less than the mean. The mean is greater. Well, what about if we have a skewed left distribution? Well, once again, the mean gets pulled towards the tail. And if the mean gets pulled towards this low end, this left tail, that means that the value of the mean is going to be less than the value of the median. So the shape of a distribution can give us an idea of the relationship between the mean and the median. If we have a symmetric distribution, the mean and the median are equal to each other. If it's skewed to the right or positively skewed, the mean is going to be greater than the median. But if it is skewed left or negatively skewed, the mean is going to get pulled towards the tail and the mean is less than the median. So all of that are big ideas for section 2.2. Hopefully this helps and hopefully you have a great day.